Hello everyone and welcome back. You are watching I Can Code Now, and in this video we will talk about pointers in C++. Pointers are basically used to point to memory locations, and in order to point to memory locations we use addresses. What is an address? An address is something that is in memory, and everything that is stored in memory is got by an address, have an address. So since pointers are used to store memory addresses, we need to have we need to store address of a valid memory address where a value is stored. So pointers act as a data type but are not but they can only store addresses, memory addresses, and those memory addresses have special format. So pointers store memory addresses, and they don't change. So the address is of always of fixed size, no matter which type of address that is. It is always of fixed size. So basically, in x64 systems, it's around 8 bytes always. It doesn't change. For example, for the integers and floats and doubles, the size changes, but for the pointers, the size remains the same no matter where it points to, or no matter what type of address it stores. And one thing other to keep in mind while we are going through this video, that the pointer must store or must point to a valid address, and the pointer that is pointing to and the value that is pointed by the pointer both should be of same data type. So basically, you cannot have an integer pointer that is pointing to a memory location, and at that memory location have a double value, because integer pointer cannot point to a memory location which is basically a double value. So to point to a memory location where the integer is stored, we need an integer pointer, and to store and to point a memory location with a double value or a character value or anything of a specific data type is stored, we need a specific data types of same data type of pointers in order for this to work in C++. This star here is important because in C++ pointers are declared using this asterisk. Let's look at this simple example. In C++, we have written this small, easy, simple, basic code, and we normally declare variables using this format like int n money, and we store it. We give it a memory location, and that memory location we store a value of 30 using this initialization or assignment statement. So this is declaration, and this is assignment. Now, in order to declare a pointer like this, we declare integers like this, and in order to declare an integer pointer, we use this format. So to declare an integer pointer, we write its data type, and then we write this asterisk or star in front of the data type. So this is a pointer that we will be using to point to a memory location, and at that memory location an integer must be stored. No other variable or no other data type can be stored at that location, because in order to point to a memory address which is an integer, we need an integer pointer. So this is only valid if both data types are same, the data type of a pointer and data type of the variable it is pointing to. Now we have declared this pointer, but how do we assign a value? And since we know now that pointers can only store addresses, they cannot store normal values like we have seen. So in order to store an address, we use this format of this address operator. So this is the declaration of pointer, and this is the assignment of pointer, and assignment of an address to this pointer. To store an address of anything, we prefix this address operator with the variable whose memory address we want to store. So if we go ahead and then print this pointer value, we get this address printed on the screen. And this is normal because the pointer is storing the address of the value and not the value itself. So when we print the pointer like this, we get the value that pointer is not pointing to, the pointer is having. So the pointer is having this value, and it is although pointing to this value, but the pointer itself is having this value. Let's break this down. And so when this statement is hit by the compiler, it reserves a memory space in RAM or in cache or wherever. And when this memory space is reserved for this variable. We look at it as n money, and the computer sees it as this hexadecimal address. And moving on, when the compiler sees this line here, it is an assignment statement. So it copies this 30 into that reserved memory location, and we have 30 assigned to n money, or 30 assigned to this address. And when this third line is hit by the compiler, memory address is reserved again to for this pointer variable, and in order to store an address or a value at this location, the compiler hits this fourth line and gets the address of the variable that is written next to this address operator. So in this case, we are trying to say that get me the address of n money, and it goes and sees that, oh, this is the address of n money, and copies that n money address and stores it in its value, right? The p money pointer has its own address, and this n money variable has its own address, and we want to store the address of n money at the location of right, at the location of p money, right? So to simplify this more, let's quickly break down this statement here. And we are saying that inside p money, which is a pointer, we want to store an address to. So this is the first thing that we do. And when we write this line, the compiler says, okay, you're writing this signature, this sign here, so what do you want the address of, right? Then we tell it that go and get me the address of this variable. It goes and it finds that memory location and named n money, or named anything that we like. It goes and finds that memory location whose name is n money, and it then gets the address because we have written this sign here. It gets the address, and it gets this address and writes it right here. So this value p money is assigned this value, as we can see here in this block. So this is only valid. This only works if the pointer type and the pointed value are both of same type. So memory addresses, they know what type of value they are storing. So basically, the memory addresses, if we change this, the memory addresses, the reserved memory location might look something like this. That every memory location has its address and has its name that we see it, and they know that what type of value is expected at this reserved memory location. So if we declare an integer pointer and we tell it to get a memory address, it goes and find that memory addresses, and before getting this memory address, it sees that, okay, the type that we are getting the address of and the type of the pointer, both are same, right? If it's both are same, then the compiler works and copy this address and write it at this location. Pardon my drawing skills. I'm not so good at this, but hopefully you're understanding the stuff that I am trying to explain. All right, let's get back to the coding part. And we've seen this program declaring a pointer, assigning an address to that pointer, and printing printing the value of that pointer, which basically prints the address that is assigned to it. But what if we want to print the value that the pointer is pointing to, not the address, but the actual value which the pointer is pointing to? And for doing that, we use this dereference operator. Dereference operator. That's right. Yes. When using star on the left hand side, or with a data type, the compiler knows that we're trying to declare a pointer, and when we start with the pointer itself, with the pointer name, the compiler knows that we're trying to dereference it and dereference it. But dereference, it means that we're trying to, it says that uh, go to the address I am storing and get me that value, right? Let me break this down further. So when we basically write this line, and we write this star, and the compiler then says that, okay, you want to get some value, but of which address you want to get the value of. Then we tell it that, okay, go to an address which this pointer is storing, right? and the compiler then goes and replaces this in this variable with its value, which is this, and this is basically what happens behind the scenes. And then the compiler knows, okay, I want to get the value of this address, which is at this address. So in this case, the value which is at this address is 30. So the compiler then replaces this whole thing with the value. This is the process of dereferencing. Dereferencing is very basic when we use pointers. Dereferencing is the basic thing that we deal with when we're using pointers. All right, and so now you know that how to dereference a value or an address by using this dereferencing operator. And now you know that this address operator is used to get the address of anything, of the variable next to it. So we can also use this other than the pointers. This is not the only, this does not only work for pointers, but we can usually use it normally without even pointers. If this is code does not exist, this still works, right? We can get the address of this variable or any other variable by using this address operator. So as you can see, if we try to print the value of n money, we want to print the address of n money, and we use this operator with the n money. And if we want to print the address of p money, which is basically a pointer, and we want to see the address, that is address of memory location that is reserved for this variable, we can use this address operator with this pointer variable as well. And this basically prints the address of each variable. So this is how we print the address of a variable, no matter what type it is. It can be integer, double, or pointer itself, or any user-defined data type, or the structure, and other function and things like that. In order to print the address at which that thing is stored, we use this address of operator. And like normally, if we want to print the values of that variable, we simply get rid of this address operator and we write this variable names. And in this case, n money is an integer and p money is a pointer. So we can see in the output that printing the value of n money prints 30, and printing the value of the pointer prints the address. Its value is an address, so it basically prints the address. But if we want to see the value at that address, we can obviously use this dereferencing operator. So dereferencing works like get me the value at the address which is in the p money value. And we have discussed before that the pointers and the value and the data and the location it points to must have same data type. So if we have this double variable and we want to point to that double variable using this integer pointer, this won't work. It will give us a compiler error that is saying that type double cannot be pointed to by this integer pointer. So in order to correct that, we use double pointer to point to a double location. And we've seen before that if we want to, point something, the data type of both the pointer and the value it points to, both the values, the data type of both should be the same. For example, in this example, this is a double variable, and we are trying to point to it using this integer pointer. This won't work. This will give us a compiler error dictating the same data. You cannot use an integer pointer to point to a double value, or the double, or simply you cannot use an integer pointer to a memory location which is basically which basically stores a double value. In order to correct this, we simply replace this integer with double. So now this works because our double value is being pointed by a double is being pointed to by a double pointer. Both the data types of the variable and the pointer are the same. This works, and this is basically the idea. This is the only condition for this to work. And obviously, we cannot, or it is not a good practice to use an uninitialized pointer. So we have declared this pointer, but we have not initialized it, or we have not assigned any value to this pointer before actually using it. So if I declare the pointer and try to use this, we can have certain unknown or uncertain behaviors. For example, when I printed this code here in VS Code, I got this output. So it tried some arbitrary address that I don't know of, that the compiler compiler got some garbage address and tried to get the value at that address, and it got me this value, which is not useful for me. It is not good. Yeah. And when I try to compile this program in VS 2022, VS Studio 2022. This is in VS Code and this is VS Studio. In VS 2022, it did not allow me to compile. This was a compilation error saying that we cannot use an uninitialized local variable because we have not initialized this variable, this pointer. So it is always a good practice to initialize variables. We can assign these values later on, but to it is always a good practice to initialize it with some value. And we can, if we are not certain of what value we need a pointer to point to, we can begin declaring this pointer by giving it a value of 0. 0 is an invalid value which is given to the pointer, and so basically the pointer at least does not try to access some random memory address that is out of the scope of this program. So good practice is to initialize it with 0, and instead of 0 we can use this null nu capitalized and null word. This is a macro that is in C, in older C, in C++ language. This basically is zero. So we can use this format, this keyword in C++. And also in modern C++, since C++11, this null PTR was introduced, which is basically used for pointers to initialize pointers with null value, with the pointers that do not point to any memory location. We use this null PTR. This null PTR is recommended, and it is only available in C++ or in modern C++. So when we have initialized this value with null PTR, now when we try to, since since this value is now not uninitialized and it is initialized basically, yes. So when we try to access an uninitialized pointer, we got a compilation error in VS and in a random value in VS Code. But now we have initialized it, but we have still initialized it with a null PTR value, null value. And when we try to access a null value, we we basically get this exception. Exception is not a compilation. This program will compile, but at the runtime, when the compiler hits this line, when the program hits this line, and when the CPU or the memory hits this line, the CPU hits this line, the exception is thrown. And it is a runtime exception. It's saying that we are trying to access something that we are not allowed to access, and then that something is an address which is null PTR, which is basically something a 000 address in memory that we are not allowed to access. All right. So this should sum up everything that we need to learn about pointers. And in another video, we'll talk about how to pass these pointers to functions and basically assign pointers to other variables, or to pass pointers around in the program, so they become more useful. But one thing to keep in mind that pointers are in C++ are a very powerful thing. They help us increase the speed of the program, or the speed of the programming, because we basically have this direct access to the memory addresses, and we can manipulate those values at those memory addresses. But with power comes responsibility. You need to be very careful when using pointers, because using pointers you are directly accessing the memory, directly accessing the RAM itself, and we're trying to manipulate the RAM. So we use pointers to gain speed in programming, but that comes with a price of responsibility of caring, because it's a duty of the programmer to make sure that we are not trying to access something we are not allowed to, we are not supposed to. So this should be it, and I'll see you in the next video. And in some other video, we'll talk about how to pass these pointers to functions and how to declare these pointers in classes and things like that. So uh, stay with us. I'll see you in another video. Thank you, guys.